Hello, honors classes. That's right. You honors classes are the only ones that get this learning target, so you must feel pretty special today. So we're dealing with learning target 8 today. I can construct an equilateral triangle, a square, and a regular hexagon inscribed in a circle. What that just means is all the vertices or the points on these shapes are going to lie right on the circle. Okay, so follow along with me if you could. First of all, I'd like you to make a point. We're going to construct an equilateral triangle inscribed in a circle first. So put the center of your compass on that point and pick a point on your compass. Just remember, you're going to use the same one later on. So I'm going to go up 1, 2, 3, 4, 5, 6 holes here. And I'm going to make a nice mark. Let's see. 2, 3, 4, 5, 6. Yep. All right. So we're good there. And you didn't have to make it the exact same size as me, but I'm just making it that big. I'm going to put another point here on the circle. And I'm going to make the same size circle that I made before. 1, 2, 3, 4, 5, 6. Again, you could have used a different hole. I'm just using this hole. And notice, when I make my circle, one part should be out here, one part should be out here. Okay? All right. Next. Now, what I'm going to do next to construct this is make a point here where the circles intersect and connect those. Okay. All right, that's going to be one side of our inscribed triangle. Now, what I'm going to do with my compass, I'm going to put one end of my compass here, and I'm going wherever the end of this segment is right here. I put pen through that hole, and I'm going to make another arc. So it looks like this. I'm going to make a point right here. All right, now I'm going to connect these points right here. And I'm going to connect these points right here. And now you can see this is an equilateral triangle. You can measure it if you want. All the sides are the same length, if you did it correctly. And all the vertices, we'll call this vertex A, B, and C, they're all on the circle. So there's the first one. That's number 1. All right, second one we're going to do is going to be an inscribed square. So I'm going to flip my paper over. And you know what? That's showing through, so I'm going to get a new sheet of paper here. And first of all, with my compass, I'm going to put a dot in the middle of the paper. And I'm going to make a circle. I'm going to put my mark right here where this 1 and there's a 2r point, 2 pi r, I don't know what it is, 2 inches radius, something like that. You can use whatever hole you want, but use this one. Construct a circle. Now I'm going to put a segment going through that circle. It's got to go through the center of the circle. All right, so it divides the circle in half in 2 hemispheres. Next, I'm going to make 2 congruent arcs. Now, I'm going to put center of my compass right here on this point. And I'm I'm going to put, looks like just past the 3 in this hole. I'm going to make a big arc going way up and way down. Then I'm going to do the same thing on this side. All right, now what I just did is I want you to remember when we constructed perpendicular bisectors, that's basically what I'm doing. I'm cutting this in half again. So I'm going to put a point up here, point up down here where they intersect, and we'll connect them. All right. Now I originally cut the circle in half. Now I cut that in half again. Now I have quarters. How many degrees are in a circle? Well, there are 360 degrees, right? So if you take 360 divided by 4, each one of these is going to be 90 degrees. That's important because in a square, each angle is going to be 90 degrees. I'll tell you about that in just a moment. All right, so now I want you to put points, each of these intersection points. And connect them, make line segments here. Now I've just constructed a square inscribed in a circle. It's inscribed because all the points are touching the circle. And one of the things we're going to learn about later is that there are 180 degrees in each triangle. Well, I told you that this was 90, right? And later on in this school year, we're going to prove that these two are going to have to be 45 degrees because they're base angles of an isosceles triangle. So if that's 45 and that's 45, that makes these all 90-degree angles. For a square, it has to have 4 90-degree angles, and these sides are all congruent. So ABCD is a square inscribed in a circle. All right, you ready for the last? That was number 2. Ready for the last, the most fun one? All right. Let's see, I gotta get another sheet of paper here. And that is a regular hexagon inscribed in a circle. All right, this one looks fun and neat when we're done. Start off with a point in the center, and we're going to construct a circle first of all. Now remember, again, where your radius is. You can make this whatever size you want. I'm going to put this by the 1, the 2 are. Okay. Now, I want you to remember, again, that point. That's going to be important here. Now, somewhere along the outside of the circle, make a dot, a point. Now, we're going to start at that point. We'll call it point A. And put the center of your compass over point A. And put your pen or pencil in the hole you used before and make a little mark like this. And intersection point, label that B. Now we're going to start at point B. Put the center of your compass right on point B. Make another same size arc. It's going to be point C. And going around, point D. Point E. And last but not least, point F. So So we have 1, 2, 3, 4, 5, 6. Guess what? A hexagon has 6 vertices. Also has 6 sides, and we're going to make those 6 sides right now. We're going to connect each of these points to make our regular hexagon. Now, why is it called a regular hexagon? Regular shape has all congruent sides and angles. So each one of these sides is the exact same length. Each of the angles is the exact same measure. So this is construction number 3. Now, I'm also attaching some other videos after this, so you're going to turn these in to me, Mr. Fischel. I'll put in here, turn in to Mr. Fischel. And I also want you to watch the videos that go with this. And listen. Very important. There's a reason that these constructions work, and it'll explain why the constructions work like they do. So thanks again, and congratulations, honors students. This is something that the other classes won't get to do. So one of the perks or nice things being about being in honors. We'll do a lot of other things that the other classes won't get to do later too. So, all right, talk to you later.